So hello everyone. Welcome to day 2 of NDC. How's it going so far? We're about the halfway mark. Everyone enjoying it? It's good to be back in person, right? This is my first time speaking at NDC. It's also my first time out of the country out of New Zealand, sorry, since January 2020. So I've got like a double excited thing going on. I'm like the dog like putting his head out the car window. So I'm very excited to be joining you all today. My name is Velida. I'm a customer engineer working in the Fast Track for Azure team at Microsoft. And part of my role is working alongside engineers to help them build robust applications in Azure. My focus is really on app development and modernization. So I work with engineers to provide them with architectural guidance, deep dive sessions on serverless and container technologies, helping them implement build pipelines, develop their DevOps processes, and so much more. And today we're going to be talking about developing and deploying containers and microservices with Azure Container Apps. So just to go through kind of the agenda of what I'm going to talk about today, we'll start by going over a very high-level overview of what Azure Container Apps is and what type of applications we can build with them. Then we'll dive a little bit deeper into the features of container apps, and I'll talk about how we can actually use those features to develop and build our applications for container apps. And then I've got a couple of demos where I'll show you different ways where we can get started with container apps, so basically provisioning container apps, and then I'll start evolving those demos into showing you how that works with CI/CD, how we can actually build our container images and deploy them to container apps, mainly in GitHub Actions, but the principles that I'll show you are applicable to other platforms as well, such as Azure DevOps and GitLab. So let's dive in. So let's start with a very high level of what Azure Container Apps actually is. So who here, just a question to kind of start off here, who here kind of works day to day with Kubernetes? Doesn't have to be Azure Kubernetes Service, can be EKS, GCP, even on-prem. Okay, so a couple of you. Kubernetes is hard. We constantly see lots of engineers and customers come to us saying, look, we're looking to modernize our applications. We've got this massive monolith and we want to break it up into several different microservices. And we've heard about this thing called Kubernetes and we like the sound of it. And it's like, okay, sounds good. How much experience do you have with Kubernetes? None. And it's like, okay, all right. Because Kubernetes can be complex, particularly to those who are new to Kubernetes, this is a blocker for lots of engineers to be able to adopt containers and microservices architecture. And what Azure Container Apps tries to do is essentially allow developers to focus on their applications rather than worry about the underlying container orchestrator infrastructure. It's built on top of Azure Kubernetes Service, and it also comes with built-in support for CADA, so Kubernetes event-driven autoscaling, Envoy, and it has integrations with Dapper, and essentially provides you with opinionated services so you can not worry about what you're going to plug into kind of your microservices architecture, but you can just focus on your application development. Come on, slides. There we go. Awesome. So like I said, Container Apps is built on top of open source technology, so it runs on Azure Kubernetes Service, CADA, Dapper, and Envoy. And since it's built on top of these technologies, it allows you to kind of take advantage of of the capabilities of those platforms. So you have built-in service discovery for your microservices. You have fully managed support for HTTP, HTTP2, ingress, etc. And this gives us the advantage to be able to perform the common application lifecycle tasks, such as upgrading our applications, splitting traffic between different versions, in a much more simpler way than if we had to manage the orchestrator infrastructure ourselves. And because you're not burdened by it, you can spend more time building the services that you want to build for your customers. And with Container Apps, we can build microservices, we can deploy APIs onto it, event processing workers, background jobs, all using containers, using any programming language that we want, or any framework that we like to. Just another question. How many of you have used Azure Functions in the past? Or are you using it now? Okay, most of you are. That's cool. So the difference between Azure Functions and Container Apps. Container Apps provides us with a little bit more developer flexibility. There's no enforcement of a programming model. So when you're developing your functions, there is a kind of a program model that is enforced onto you. And there's also like a limited amount of languages that you can use within Azure Functions. If you're using languages like Go or Rust, there are custom handlers, but there's better support for languages like C#, Python, Java, etc. Whereas Container Apps, you haven't got those limitations. So if you can containerize your application, you can deploy it to Azure Container Apps, with the caveat of they have to be Linux-based container images. There's no support for Windows containers. How many of you are using Windows containers? Don't be shy. A couple of you, okay. I don't know when or if there will ever be support for Windows containers on Azure Container Apps. So sorry about that. But yeah, if you can containerize it and deploy it to Linux, you're good to go on Azure Container Apps. And then thanks to kind of integration with Dapr, which is the distributed application runtime, not the ORM Dapr, you can simplify common tasks that you would in any microservices architecture, such as pub/sub, service invocation, and event processing. Container Apps provides like a PaaS way of being able to deploy your Dapr applications, where in the past, you were kind of limited. If you were developing applications using the Dapr framework, you were limited to something like Azure Kubernetes Service. And then Container Apps also provides kind of robust ability to scale on a variety of different things. So under the hood, it uses CADA. So it uses CADA event scale triggers or CPU and memory or HTTP triggers to kind of auto scale. And you can run your containers and scale in response to, say, HTTP traffic or any kind of CADA-supported scale trigger that open source project provides. So that's kind of like a very high-level overview of what Container Apps is. Let's start to kind of explore what we can actually build with Container Apps. So really kind of the first class kind of like citizen on Container Apps is really microservices architecture. The idea is that the platform is there to kind of support developers who are building microservices but don't want to use Kubernetes to kind of have a platform that they can easily deploy their containers to. There's also, you can also build public APIs and web apps on Azure Container Apps, as I'll show you in a demo. So you can actually enable HTTP ingress onto your container apps and make them publicly available. And we can actually scale based on how many HTTP requests are coming into our container apps as well. We can also build event-driven processing workloads inside container apps. So say if you've got a container app that's listening to messages coming from a queue, we can scale our container apps based on how many messages are incoming into our queue. And we can also do some background processing. We can provision background processing workloads as well onto container apps. The amount of times I've seen customers and engineers try to force Azure Functions to do these kind of long-running background processing tasks, it can get quite painful and quite a bit of a nightmare to manage, because that's not what it's designed for. It's designed for particularly like normal functions. There's durable functions, but for kind of like normal functions, that's more designed for kind of like reacting to quick events. So it's not designed for that. So container apps, it's more suitable for those kind of background processing tasks. Now, before we dive a little bit deeper into Azure Container Apps, I do want to make the comparison with AKS, because the purpose of me standing here today, I'm not here to tell you, okay, there's no need for Azure Kubernetes Service or any Kubernetes deployment ever. Go back to your workplaces and destroy your clusters. That's not the goal here. The main focus, or the main trade-off between something like Azure Kubernetes Service and Azure Container Apps is really the trade-off between flexibility and productivity. if you need to be more selective about how you're extending your cluster and what kind of add-ons you're putting on into your Kubernetes environment, Azure Kubernetes Services is a great choice for you. If you don't really want to worry about managing the infrastructure of your container orchestrator, and you don't want to deal with the complexity, Azure Container Apps is a good option for you. Bear in mind that with Azure Container Apps, if you're running kube control commands against your Kubernetes clusters, that's not going to be supported for you in Azure Container Apps. Cool, so let's dive a little bit deeper into some of the main concepts of Azure Container Apps. So we start off with a Container Apps environment. Individual container apps are deployed to a single container apps environment. Now, for those of you coming from Kubernetes, you can really think of this as like a namespace. And this acts as like a secure boundary around groups of your container apps. Container apps in the same environment are deployed to the same virtual network, and they write logs to the same log analytics workspace. When you provision a container app environment, a VNet acts as the boundary, and you kind of have two options. If you just want to deploy an environment, a VNet is automatically created for you, but that lives in our tenant. So you don't have any visibility of that VNet. We take care of that, and we look after it for you on your behalf. However, if you have an existing VNet, or if you want to create a custom VNet that you'd like to deploy your container apps environment to, you can do that. And that's created in your subscription, your environment, and then you can take care of that. Now, inside our environment are the container apps themselves. And simply put, this is just kind of like a single independent microservice that includes our desired state configuration for our container app. And in there are the actual containers. So container apps manages the details of Kubernetes and container orchestration for you. And containers can, like I said earlier, use any runtime, any programming language, and any development stack of your choice. There's support for Linux-based container images. You can pull containers from any public or private container registry. So if you're using a private container registry, such as Azure Container Registry, you can build and deploy and store your images in the container registry, and then configure your container apps to pull images from your container registry into your container app. The caveat here with container apps is it can't run privileged containers or any processes that require root access. That's a limitation of Azure Container Apps today. You can't do that. There's no required base container image, and if your container crashes, underneath the hood, the container app will automatically restart for you. Now, one pattern that you can use with your containers, you can define multiple containers within the same container app. And this means they'll be co-located and scaled together. The purpose of this is not to run multiple microservices within a single container app. This is more suited for kind of those sidecar scenarios where those sidecar containers are running alongside your core workload container. And then we have this idea of revisions. So this is where we start to get into, okay, how do we actually deploy different versions of our container app, and how do we manage traffic between different versions of our container app? A revision is an immutable snapshot of our container app. Now, in container apps, we kind of have two modes of how we can actually manage revisions. We can have a single revision mode, which is the default, or multiple revision mode, and I'll explain the difference between those in a second. So take the following example. So when we first provision our container app, a revision is automatically created for us. And as we make changes to the container app's template configuration, and these can include changes by the environment variables that we use, how much CPU and memory we're allocating to those containers, the container image itself, what image are we actually using for our container app, new revisions will be automatically created. Now, revisions are immutable, but if we make changes on a global configuration scale, it's going to apply to all of our revisions. So for example, if I'm using secrets in my container apps, and I'm changing the values of those secrets, all of the revisions within my container app are going to be affected by that secret change. So say, for example, you've got a secret that's got a connection string to a database. If a previous version of your app was using an older secret pointing to a different database and you change that, your older revision is going to point to your new connection string for your database. So it's just something to keep in mind. The power behind revisions is, this is really useful when you enable ingress or to make your container apps accessible via HTTP. In the demo that I'll show in a little bit later, revisions, we often use revisions for direct traffic between one revision and another. And this opens up some really powerful deployment scenarios, such as A/B testing and blue-green deployments. So just to kind of like summarize the differences between revision scope and application scope changes, revision scope changes are changes that we make to the template of our container app. So this is revision suffix changes. We can actually apply a suffix to our revision to make it easily identifiable. Changes we make to our container, and image changes, and also the scale rules. So if we're changing how we're scaling our container apps, that's a revision scope change. And then for our application scope changes, this is our changes to the configuration of the container app itself. So changing secret values, changing the revision mode as well. So it's not like you're stuck to it's not a hard choice between single and multiple. You can chop and change as you need to. How you're controlling ingress, if you're using Dapper, the settings you're changing, that's going to apply to all of your different revisions. Now, as the name might suggest, two types of revision modes. So a single revision is when only one revision of your container app is active at any time. So as you're changing and updating your container images, the latest version that you deploy will be the only version available to your container app. Whereas multiple revisions is where you can actually run multiple revisions of your app simultaneously. We can use revision labels to kind of direct traffic between different versions, and all your revisions will remain active until you go and deactivate them. Now, there's a hard limit of 100 revisions available to each container app, because you've got to distribute 100% of the traffic. If you have a use case where you want to keep 100 revisions active and direct 1% traffic to each one of them, I'd love to hear about that. But that's just kind of like a hard limit of how many revisions you can have. To talk about replicas, the unit of scale in Azure Container App is called a replica. And this is just essentially how many replicas are going to be available to a particular revision of your container app. Now, one thing to note is that when you're running in multiple revision mode, depending on how you configure your replicas and your scale, each revision is going to have its own scale rules. So for example, revision 1 of my app could have 10 instances of that revision running, while if I change the scale rules to say, okay, I don't really want 10 instances of this application to run, and in version 2, I define the upper limit to 5, that's going to have its own scale criteria. So if you're running in multiple revisions and you're directing traffic to different revisions, just bear in mind that the scale rule will apply to that particular revision. Let's go into networking. I'm not going to go too deep into networking. I'm just going to kind of like take it at a high level overview and just kind of explain the differences between like internal and external environments. So container apps run in this container app environment, which is supported by a VNet. Like I said earlier, if you don't want to use a pre-existing VNet, we manage that VNet for you, but you don't have the ability to access that VNet. And with container apps, we can have two types of environments. We can have internal environments or external. An external environment is just essentially saying, okay, container apps provisioned within this environment are available for public requests. And the environments themselves are deployed with a virtual IP on a public external IP address. Internal environments have no public endpoint. They're deployed with a virtual IP mapped to an internal IP address, and the internal endpoint is just an Azure internal load balancer. And IP addresses are issued from custom VNet's list of private IPs. Now, with container apps, we actually allow you to expose your container apps to the public web by enabling ingress. When you enable ingress, you don't actually have to go and create a load balancer, a public IP address, or any other Azure resources to enable incoming HTTP requests. And when you enable ingress, your container app will have support for TLS termination, HTTP and HTTP2. Endpoints always use TLS 1.2, and the endpoints always expose port 80 for HTTP and 443 for HTTPS. Now, your ingress IP and fully qualified domain name can either be visible publicly on the public internet or internally inside the VNet. And with ingress enabled, your application is assigned a fully qualified domain name, and your container apps environment has a single IP address for applications with external ingress visibility and a single internal IP address for internal ingress visibility. So all applications within a container app environment with external visibility, they share a single public IP address. Similarly, all applications in an internal container apps with internal ingress visibility share a single internal IP address. And our traffic is actually routed to individual applications based on the fully qualified domain name in the host header. Now, when it comes to bringing your own virtual network, there's a couple of things to keep in mind here. If you want to restrict your container app, you want to restrict all access from outside to your container app, you should look at creating an internal environment. When you provide your own virtual network, you need to provide a subnet that's simply dedicated to that container apps environment that you're going to deploy. Network addresses are assigned from the subnet range that you define as the environment is created. That's used by your container apps environment, and then once the environment is created, that subnet range is immutable. And each revision of our container app will be assigned an IP address from that subnet. Cool, that was a very high level of how networking works in container apps, so if you do have questions, just feel free to ask at the end. Cool, let's talk about logging and observability. So container apps provides several built-in observability features that kind of gives us the ability to have an holistic overview of our container app's health throughout our development lifecycle, which helps us monitor and diagnose the state of our applications. Now, there are different ways of monitoring it depending on what stage you are at in your dev test phase. So we can access our logs in real time through log streaming, and also we can actually connect to our containers console during the dev and test phase. Once we deploy our container apps into our production environments, we can actually use this integration with Azure Monitor and Log Analytics to analyze metrics, receive alerts for critical conditions, and view application logs using Log Analytics. So yeah, streaming logs are just essentially a view of a stream of your container's standard out and standard error messages. You can access this either through the portal or through Azure CLI. And then for the console connect, we can connect directly to the containers console. And this is really useful for troubleshooting situations. Again, this is accessible through the portal or Azure CLI. Now, Container Apps today is integrated with Azure Monitor Log Analytics. So when we provision our Container Apps environment, we also include a Log Analytics workspace that will provide us with a common workspace to store system and application logs that are generated from our container apps and from the container apps that are running inside that environment. Now, we can query these logs using KQL in Log Analytics or via the Azure CLI. And there are two types of logs that we can look at from container apps. So we can read console logs, and these are essentially logs that are emitted by our application, or system logs, which are just metrics, which are just logs emitted by the container app service themselves. And I'll show you how you can query those two in Log Analytics in the demo. We can also collect metric data. So Azure Monitor will collect metric data from our container apps at regular intervals to kind of help us understand how our applications are performing, how healthy they are, etc. These include metrics on CPU usage, working memory, how many requests are coming in, how many replicas are active, etc. And what's really powerful here, from these metrics, we can actually use and set up alerts from Azure Monitor to test against certain thresholds. And I'll show you how that works in the demo. Just to kind of talk about scaling. So underneath the hood, Azure Container Apps uses the CADA autoscaler, so Kubernetes-based event-driven autoscaling. And there are different kind of scaling rules that we can apply to our container apps. So we can do it on HTTP requests. There are support for various different event-driven triggers that we can use to kind of scale our container apps on. And we can also scale on CPU and memory. The important thing to note here is that for HTTP and event-driven scaling, there's support for scale to 0. So if nothing's happening to your container app, you can scale right down to 0, so you're not charged for it, for the container app to run. However, if you're scaling on CPU and memory, you need to have at least one replica active all the time. So that's just something to keep in mind. Cool, so that's enough slides. We're going to jump into a bit of a demo now. So if I change the way that I just duplicate. That is duplicated, Will. Cool, so I'm going to we'll start off real basic. I'm going to show you how we can provision container apps using a template, and I'll show you a bicep example and a Terraform example, because there are slight differences and support capabilities for both. Just out of interest, who here is using bicep or ARM templates? A couple of you, cool. And Terraform, who are my Terraform users here? More Terraform. That's cool. Okay, we'll start with bicep. So what I've got here, not this one, this one. So here is kind of like my bicep template. So I'm just going to get rid of the terminal so we can get some more real estate. And at the back, is that good, or do you want me to zoom in a little bit? One more? That better? Awesome, fantastic. Cool, so with Bicep, it's real easy to kind of like scaffold your container apps environment. So here I've got my log analytics workspace that I'm going to be sending all the logs that are emitted from my container apps in my container apps environment. It's going to be sent to this log analytics workspace. I've got an app insights workspace here because it's important to point out there's no direct integration currently with container apps and application insights. However, within your applications, you can basically use the instrumentation key, or better yet, the connection string. Just to note that instrumentation keys for application insights is going to be retired in 2024, so make sure you're using the connection string. If you provide your container app with the connection string, you can still send logs that are coming from your applications into application insights. And then you can integrate that with log analytics. Here I've got my environment. So here I've given it a name. I've got my location. And I'm configuring my logs to be sent to log analytics. Currently, at the moment, there's only support for log analytics. Future integrations, I'm not sure when or if, so I can't really comment on that. But here what we're doing, we're just configuring our container apps environment to send logs to our log analytics workspace using the customer ID and also the primary shared key. So it's fairly straightforward to kind of set up. If I was to integrate this, or deploy this, into a VNet, I'd also configure it with the environment level as well. And with VNet support as well, you can actually make your container apps environments zone redundant as well. It's actually a requirement. So if you're using availability zones for your architecture, well done. But you have to provide your own VNet to do that with Azure Container Apps. And then here, I've just got a really basic container app that's going to be deployed to that container apps environment. So here, I'm just saying, so the managed environment ID, I'm just saying, okay, this container app is going to be deployed into this, this environment. I'm setting my revisions to multiple, so this container app can have multiple revisions active at any time. I'm enabling ingress. I'm just using HTTP for the target point of 80. And then for my container, so I'm defining the image, I'm providing a name, and I've got some environment variables here that this container app, is going to can use within its application. And then I'm also defining some scale rules. I won't do any scaling within this demo, but this is, we can actually define minimum and maximum replicas. The hard limit for max replicas at the moment is 30. That will grow over time. When and if, again, can't comment, sorry. And there's also support for managed identities as well. So today, if you're developing Azure Functions and you're using role assignments to grant your functions access to a database or a message queue, you can do the same within Azure Container Apps as well. So there's support for that, which is really good. And it prevents us from using secrets within our application as well, which is something I'm a big proponent of. So if I'm just going to run that visualizer, you can see there, very basic. There's my environment, there's my container app, my app insights workspace, and my log analytics workspace all working together as just kind of like a basic container apps environment. One thing that I will add, I've also got within this folder a YAML file. So it is possible to define your container apps in YAML files. I'm reluctant to use the word manifests because these are not your Kubernetes manifests. Anyone here who's worked with Kubernetes can see it's a different kind. This isn't a deployment. I'm not defining a Kubernetes deployment. I wouldn't be using the kube control to deploy this YAML file. It's just if you're used to kind of like developing and provisioning your services using YAML files, there is the option of doing that in container apps. Just taking my Microsoft hat off at the moment, it's not great. Here, I'm keeping this very, very simple. I'm not defining which container registry I'm using. I'm pulling a public image, so I don't need to. There's a lot of things in here, so like the name of the container app, the resource group, certainly the environment ID that I'm going to deploy this container app to. A lot of those things I would parameterize. And support for that at the moment's not great, but it is being worked on and getting a little bit better. So to deploy this, I'll open up my command prompt. I'll do a little bit of copy and pasting just for time. And with the Azure CLI, we have support for operating against our container apps using the Azure CLI. So here, all I'm doing is, okay, I'm going to create a new container app. I'll actually increment this a little bit because I've built one before, defining it in this resource group using that YAML file. So if I press enter, I'll let that run. Essentially what the command line should do is have a look. I'm not in the right folder. If I actually navigate to the right folder, what it should do, what I'll do is, I'll actually use the terminal inside here rather chopping and changing. And then I'll just cd into bicep and YAML, copy and paste that. All that's going to do is going to read my YAML file and it's going to create a new container app. See some of the warnings here saying, okay, some of the values are provided on the command line have already been provided in the YAML file, so I'm just going to have a look at the YAML file and just take those values instead. So it's just something to keep in mind. And so if I navigate into the Azure portal, I've got my resource group here. Here's one I made earlier. So there's the container app that I've defined in my YAML file, ready to go. So a real basic scenario there of having a bicep template. You can provision a container app there, and you can also provision container apps using YAML files. You can't provision container app environments, though, using YAML. So if I was to state a preference, use bicep. There's better support for it. There's better support for parameterization, etc. And then to just kind of quickly go over Terraform. So Terraform has, it's doable. It is doable. But for those of you who kind of follow the Terraform project, and particularly follow the Azure Resource Manager provider, currently at the moment there's no out-of-the-box support for provisioning container apps using the HashiCorp Azure RM provider. So what we have another resource provider called Azure AZ API, which is kind of like a thin wrapper over the ARM API that allows us to kind of provision container apps. So here again, I'm defining my log analytics workspace, application insights, and then here I'm starting to use the AZ API provider. Here I'm providing a type for my managed environment, and here within this JSON encode, I'm just defining the properties for my container app environment and also the container app itself. And just a little trick with Visual Studio Code to kind of help you with development of that. We do have an extension that kind of supports using that provider, and it provides IntelliSense. So I'd recommend if you are using this provider, do have a look at this extension. It's just going to make your development life a little bit easier. Cool, so let's take this up a level. Let's now look at, let's explore revisions. So if I go into here, so what I've got an application that is going to listen to two APIs. So one API exposes information of how much inventory I have, and another API exposes the products that I have in my store, and I've got another container app that's just going to serve as a UI interface for that. So here, in my deploy folder here, I've got my entire bicep file. So again, I've got kind of my container app environment up here, and I've also got my container apps that are going to be provisioned to that container app environment. One thing to notice here is, again, we're defining a registry, so this is going to pull a container image from our private Azure Container Registry, but I've disabled external ingress into my container app. So these container apps can communicate with each other inside the container app environment. However, if I try to access this container app outside the environment, I'm not going to be successful. So if I actually go into the portal very quickly, go back into resource groups, and if I look at, I'll take this inventory one as an example. This will give me a fully qualified domain name, but it's marked as internal. So I'm not going to be able to access it from outside the container app environment. Cool, but what I want to show here is this idea of revision management. So if I look at this store application, I've hooked it up to Azure App Configuration, which is going to store a feature flag. And essentially, when I enable a feature flag for that particular revision, it's going to expose a beta feature to those users who can access that particular revision, which is just, if I go into pages, look at the beta, it's just that. It's just going to be a razor page that we'll be able to navigate to. So if I go into my store application, currently at the moment, I've got a revision where this feature isn't enabled, and 100% of my traffic is being stored, being directed to this current version here. So what I'm going to do is I'll just open this up, I'll get rid of you, get rid of you as well. Through the power of video editing, which we can't do in a live stage. Let me refresh that. Essentially, I want a URL. Ooh. Would it be funny if Azure went down while I was doing all my demos? Stand by, folks. I'd love to blame it on conference Wi-Fi, but I'm using the hotel Wi-Fi. Oh dear. I am offline. Thank you. Let me try again. Apologies about this, folks. Essentially what I want to do is I want to navigate to my store homepage, and essentially we're going to run a couple of commands to create a copy of our existing revision, and then we're going to run another command that is going to essentially split traffic between those two different revisions. Is it developers with just lowercase? Awesome. Let's give it a go. No S. Make sure I spelled developer properly, that'd be good. There we go. Awesome. There we go. Go back to the portal. Ignite's running on right now, for those of you who follow Microsoft a little bit. So if the Azure portal went down during Ignite, that would be very unfortunate. Awesome. Okay, so back in the portal. Go to the store. And I'm going to open this up. And there it is. There's my UI. Okay. So now I want to essentially create a revision that's going to have my latest feature enabled. So I'll just go back into my command prompt, just run CLS. And what I'm going to do, just do a little bit of copy and pasting just for time. I'm going to create a copy of my existing revision. So run through. Before I run that, essentially through the AZ CLI that I can do, creating a copy of revision, I'm specifying the name of my container app, so I can point it at the right container. And with this, we can actually set environment variables as we're creating new copies of our revisions. Remember that changing environment variables is a revision scope change. So here I'm going to be enabling my feature that I've got in Azure App Configuration, and we can provide a suffix to it. So I'm going to say beta NDC will. Remember that revisions are immutable, so you may deactivate a revision, but it will still kind of exist. So if I go, while that's running in the background, if I go into my revision management, it will show you by default all kind of like the active revisions. That's creating in the background, so that's been successful. So that's created my new revision. Hopefully it hasn't redirected traffic to it. Okay, yeah, so it's redirected 100% of traffic to it, but now we want to split between the two different revisions. So in order to do that, we're going to run another AZ CLI command. Didn't copy the A, so I'll just do that. Cool. So what I want to do, here is the revision suffix that I want to split traffic to. So here, what we're doing is we're running a command line saying, okay, for ingress, we're going to send 50% of our traffic to the latest revision, and we're going to send the other 50% to the prior revision. So that's going to run in the background, and that's going to split traffic between those two different revisions. So as that's running in the background, if I just click refresh, we can see there that 50% of the traffic has been split either way. Just let the command prompt do its thing, make sure it's acknowledged. Because the idea here is, if I keep on clicking refreshing, I'll eventually hit the page where my beta feature is enabled. Got a nervous eye on the time and the Wi-Fi, which is pretty cool. Nothing like mixing it up on a live demo. Cool, so there we go. So now my traffic has been split between those two different revisions. So if I go back into here, should be able to see the traffic's been split accordingly. So if I go back into my store UI, just give it a refresh. I've managed to land on the beta page, and now that beta has been exposed to me purely based on traffic. That's a real basic scenario of how we can use revisions in Azure Container Apps. One thing that I will note here, if I go back into my revision management, and if I actually click on this, this will give me a URL for this particular revision. So if I navigate to that, it's going to show me that beta feature enabled for me. Imagine you're developing APIs and you're deploying them to Azure Container Apps. What this does, it provides you with an endpoint that you can actually run smoke tests against. So you're developing an API, you've got new features, you run your smoke tests against that, and if your tests have passed, you can use the Azure CLI to kind of switch traffic and do some blue-green deployments as well. So yeah, that's how we can use revisions to kind of manage our deployments, open up some interesting deployment scenarios, and redirect traffic between those two different revisions. Now, one thing that I have done for this, I've defined a scaling rule for this particular revision. Okay, so for this latest revision, I've got a minimum and maximum of replicas from 1 to 30, and I've got this HTTP scale rule. So for every 100 concurrent requests to my container app, we're going to scale up by 1 replica. So to kind of visualize this, what I'll do is I will actually assign 100% traffic to you, deactivate you, save that. While that's updating, I am going to take my URL here, and I'm going to use Azure load testing to just flood it with requests. So that's real simple. So I can just create a test here. It's one I created earlier. And just have 100 users. I'll run it for 60 seconds. And while that's running in the background, I'll show you what this looks like within the metrics themselves. So if I navigate to my container app that I had open earlier, we can actually look at the metrics emitted from it to see how many replicas it is scaled up to. So around about 5 o'clock in the morning, which is 7 o'clock my time. I keep waking up at 2 o'clock in the morning. I've got like this weird jet lag thing going on. I can't, anyway. But essentially, as those HTTP requests are coming in, the amount of replicas that are being increased will scale up to 30. And then once those requests start to die down, it will scale back down to our minimum replica. And then from here, what we can do is we can actually generate, see if that's running, that is executing, that's good. We can actually generate alert rules from that. So taking that kind of replica count as an example, I can use something, say, okay, every time it exceeds a threshold of 10, I want to create an alert that's going to kind of alert my on-call team that I've defined here. And this is a really good way of being proactive and making sure that you're monitoring what's going on inside of your container apps. Now here I'm just using the portal for visibility, so you can actually understand how this all works. Please do this in infrastructure as code. You can do this in both Bicep and Terraform. Please get into the habit of creating alert rules, creating what kind of things you want to report on in terms of metrics and diagnostic settings within your code. So if you're standing up new environments, everything is just like a template deployment rather than going through the portal and spending hours and hours configuring different metric rules for different environments where you can just deploy a template. Cool. So if I create that, that's executed. So I won't actually create that, but I'll go back into metrics, and hopefully there won't be, not for you, for my store, there won't be a bit of a delay. There is a little bit of a delay in metrics in Azure. If I look at my replica count, see it's scaled up to 30 replicas again. And in a little while, once things have calmed down, it will scale back down to 1. So we can define scale rules within our container apps to kind of control how our container apps are going to scale. Now, one thing that I do want to point out with this sample, this kind of deploys container apps alongside the container app environments, its log analytics workspace, its app insights. And in kind of like real world scenario, this is a good sample. So essentially part of my role is we create quick start templates and samples. So that whole deploy to Azure button, we create samples so you can essentially just do that. But in real life scenarios, it doesn't translate. There's kind of this concept of you'll have your core infrastructure, which would be shared between different components of your application. I know that with microservices design, you want to try and like isolate data sources to each service, but inevitably things, and it does make sense, where some resources will be shared, such as the key vault. So what we can do using Bicep, and this is possible in Terraform as well, we can actually split the infrastructure for our core infrastructure and also split out the infrastructure relevant to that particular container app or particular service, I should say. So in this file, this is kind of like my core infrastructure. So in a container apps world, we've got our log analytics workspace, we've got our container registry, and also our container apps environment. And here I've got several different services. So I've got one for my catalog, ordering, and web. So if I go into my catalog here, I can see this infrastructure. I've got this Bicep file for this infrastructure, and these are relevant to that particular service. So here I'm just using, let me get some real estate going. Here I'm referencing the existing container registry that I've provisioned in my core infrastructure. I've got my key vault, container apps environment, and here I'm using a module for a container app. Now with Bicep, you can actually deploy your modules into something like Azure Container Registry, and this is what I'm doing here. You can use local modules as well. It really depends on your use case. But here, all of these resources that I'm defining in my Bicep template are relevant to my, my catalog service. And this makes life a little easier when we're actually deploying our services. So if I look at my deploy store YAML file, this is a GitHub Actions workflow file. So here, all I'm really concerned about is my, wrong one, that's it. All I'm really concerned about is my core infrastructure. So I'm doing some linting on my Bicep, I'm validating my Bicep, doing some previews. It's good to have controls and deployment gates throughout your deployment so you can actually control what you're going to deploy. And then I've got a stage where I can actually manually approve that deployment to my production environment. And the advantages of kind of separating this out, here in my core infrastructure, I'm only really worried from a container apps perspective about my container apps environment. So by kind of isolating my container apps deployment in another file, another workflow, so this is one for my container apps workflow, here I'm provisioning the infrastructure relevant for this service. I'm validating it like I'm doing it for my core service, and then I'm deploying the infrastructure, and I can deploy my infrastructure alongside my containers. So once I've built my infrastructure and it's ready, I can start to build my API, containerize it, store it in Azure Container Registry, and then deploy it to my container app. And it's also good because we're running tests on our API project as well. Before we start building it, you can also use this approach to kind of test your infrastructure code and also do some security checking on your kind of container images and scan your container images as well, rather than what we were doing earlier in kind of like the A/B scenario, where essentially we're kind of deploying everything at once. And using this approach, you do run into the risk of kind of creating redundant revisions. So kind of the takeaway from that is to really have a think about how you're going to be structuring your microservices architecture, and just think about how you're going to deploy the different services in a way that's easy to manage and also easy to kind of retire when you don't need it. Not everything, even though when we think of microservices architecture, we think of, we're kind of building new services for the future. It's important to have application lifecycle in mind because there will be a day where you have to retire a service or a domain because it's not relevant to you anymore. So by isolating it into its own kind of domain, you get the advantage of being able to switch on and switch off capabilities as you go along. So if I go into GitHub for this, just looking for time. Don't want to confirm my settings right now, thank you. So there are my workflow files. If I go into actions, and I'll look at one that I ran earlier this morning, here we have the ability to kind of just look at controlling our deployment for our infrastructure. And then once our infrastructure is deployed, we can start to build out our API project and build our container image and then deploy our container image from Azure Container Registry into our container app. Just having a look at that. That job takes 10 minutes to run, and I've got 4 minutes left, so I won't make you watch me provision infrastructure. So hopefully you guys get an understanding of like how you can start to formulate your infrastructure code in such a way where you can kind of like split it up into various different components using kind of container apps. So what I'll do is I'll just kind of wrap up here. So container apps, the aim of container apps is to really help developers shift their focus from having to maintain complicated container orchestrators and really focus on their application. At the end of the day, we're here to build new features that are going to be valuable to our customers and our users. We don't want to have to waste time if we don't have the skill set to worry about things like Kubernetes if we don't have to. And what this does, it actually helps us perform application lifecycle tasks such as upgrading, traffic shifting between different versions, and versioning itself in a much simpler way than we would have to when we're managing a container orchestration system. Container apps does come with built-in observability with Azure Monitor today. If you're using something like Splunk or Elastic or anything else, I don't know when or if, but I wouldn't be surprised in the near future those integrations would be coming. And there's support for internal and external networking. So when you're designing your kind of like microservices architecture, do have a think about how networking is going to be involved in that. It's not like Kubernetes where you have to plan for how many pods, what kind of networking plugins you're going to be using, etc. But it is worth considering. And then there's also support for kind of great open source projects. So there's support for CADA, Envoy Service Discovery, and integration with Dapper. So rather than having to look at the massive CNCF project list and decide which kind of flavors you want, this is provided for you. Awesome. Thanks for listening. Thanks for sticking with me when the Wi-Fi went down. I knew something was going to happen, so that was fun. If you have any questions, you can ask me here, or you can feel free to reach out to me. I'm on Twitter, or reach out to me at Microsoft. I'm going to be hanging around at the conference as well. Yeah, thanks for coming.